Hello? Yeah. Okay, guys, so first of all, I don't know if you actually know what I'm going to be talking about, because the title of the session is kind of hard to understand, maybe. So just for setting expectations, I'm going to be talking about a social game we created at 3 Melons, the game studio I work at. And we hosted this game on Azure, so I'm going to be talking mostly about our experience in putting this game into the Azure platform and dealing with very, very high loads. You know, social games are massive in user scale. So we deal with a lot of traffic, a lot of users, and we want over the whole experience of launching this on Azure. So I'm going to be speaking about my experience with the Azure platform for this particular game. So a little bit about ourselves. 3 Melons, it's a game studio. We are based in Buenos Aires, Argentina. And we are trying to do that, deliver experiences, fun experiences, compelling experiences to players all around the world. And we've been doing games for different companies around the globe for our first part. I don't want to sell you anything. You'll see that it's just an introduction. We did games for Lego Star Wars. We did Indiana Jones game. And we finally did Bola. And I'm going to be talking about Bola, which is a soccer game, a social soccer game. And when we did this, we got acquired by Playdom. Playdom is a leading social gaming company in the Silicon Valley, who was later acquired by the Disney company. So I'm now part of the Walt Disney company. So it's a long story. But I'm not here to talk about that, but I'm here to talk about our experience with Bola. So what is Bola? Again, it's a soccer game. You can find it on Facebook, Orkut, and different social networks. It's supported in more than 7 languages, and it's integrated into the whole social ecosystem and into the different platforms. I'm going to show you, if I can, a video of this game so you get an idea of also about the experience of creating your own club, customizing it. You can get sponsors, and these are actually real sponsors. We created deals with them, so they use our user base for reaching these brands to all these people. And I'm talking about millions of people. So we launched this game. Anyway, this is a platform that is not here to talk about the front end, but also the back end. We launched on the Soccer World Championship. Back to the presentation, if I can. Here we go. So, it was there. So, the important thing is that we grew very, very fast from known users to almost 6 million monthly active users in about 7 months. That's what was pushed in an important way by the Soccer World Cup, of course, and all the stuff going on around the soccer. But it was really, really massive. And again, I want to show you how was our process for defining how we launched this game over what platform and why we did the decisions we did. So cloud computing was the first word that came to us in order to define where we were going to host this game, because we knew that a social game needs millions of users to be to give some money back, right? So we needed to scale. We didn't have money. We were a startup at the moment, so we couldn't invest in upfront for technology, data centers, or whatever. So we saw the cloud computing movement as the way to go for this game, mostly because, again, no upfront investments. We, instead of putting CapEx, we moved that into the OpEx in the balance. It was basically a good platform for scaling up in ways that we couldn't predict. So it's elastic. You can scale up and down very easily. And I'm going to show a little bit about our architecture and how we deal with this for being agile in the elasticity. And, of course, paying just for what you use. If our game was not a success, we wouldn't have to pay to the hosting provider. So that's an aspect that most of the cloud computing providers give you. So why Azure, then? There are plenty of cloud computing solutions, right? So mainly because, first thing, we are a gaming studio. We are not a technology company. So we are not focused on IT and sysops, DBA stuff, right? It's mostly creative, art, animation work. And of course, there is software and there's code involved in creating games, but our focus was most on user experience than backend databases and that kind of stuff. But we were using Visual Studio for creating some of our games that I showed before, like the Lego Star Wars game. And we were used to C#, .NET, and used to Visual Studio tooling. And the truth is that Visual Studio integrates really, really good with Azure and makes the developer's life easier to deploy, to maintain, to test. And we weren't willing to invest in retraining our people into a different platform or different language. This is our people. You'll see their faces. They're not sysadmins or nothing like that. So we didn't want that. Okay? We didn't want it to deal with hardware maintenance, operating systems, tweaks and optimizations, patching, all the stuff that goes when you need to maintain your own data center. Even if you have a hosted one, you're responsible for patching the OS, for tweaking the databases or whatever you need for your special solution. This is not the case in Azure. In Azure, mostly that part is solved for you. There's a team in the Azure platform that has the responsibility to make all the virtual machines work, all the ecosystem upgrade every time it needs to upgrade. So kind of we pushed the risk somewhere else and focused on what we do best, that is create games. Okay? So that was our line of thought into getting Azure as our hosting platform for this game. I didn't mention it, but I told you about millions of monthly active users. That translates into our maximum peak was 1.2 million daily active users. Okay? And that translates into about 80,000 concurrent connections, and there's a lot of requests per second that goes after that number of sessions. So it's really, really high load and unpredictable scalability. Okay, so this is our basic solution. This is what I want to focus today. So the very basic thing, and this is like in chronology, how we started and how we evolved our solution. We started just with a plain Flash client, talking to the social networks directly, and a web server that is a web role in Azure that is totally scalable and has a load balancer in front of it and everything, but that's transparent to you. You don't need to be in the details and specifics. You just put the number of instances you need, and it scales up and down almost automatically for you. And we chose to go with a NoSQL solution because mainly our games store data from one user at a time. It's like when you go into your game, you're seeing your own stuff, right? And then you can visit another friend of yours and go and see the snapshot of his status on the game, but you're not doing what would eventually translate into a relational database. So we didn't have a need for foreign keys, joins. So it's basically key value store. We put some stuff there and we retrieve all together. That's at least was how we thought initially. Later we realized there were some scenarios where we needed a little more relational stuff, and I'm going to talk to you about how we deal with that. So we used Azure Table Storage as our storage layer. Why? Well, I want to go much into the details, but it basically allowed us to scale without much knowledge of the underlying technology for the storage layer. Kind of, you don't need to deal with data center, database, or administrate a database. It's just a bunch of known rules that I put over here, and the idea that you need to deal with that based on your specific solution. So basically, if you partition correctly your data, you will be fine with this. I'm going to do a last slide where I talk a bit about how to deal with the things. But basically, it's a REST API, and you consume that from your process, okay? Your process can be a web server or a worker role, yeah? So the first problem we had was to deal with the fact that the users were coming very, very quickly into our game, and we wouldn't be wake up all day monitoring what's going on with our load and adding servers to the infrastructure. So the first thing we did was to create a monitoring scaling server. We used a worker role, Azure worker role, that is basically a place to deploy a process that doesn't need to be heated by an external source like an HTTP connection or anything like that. It's just your code running somewhere, okay? Periodically, you can create your scheduling stuff or whatever you need. And what we did there is consume the Azure API for monitoring. It's the diagnostics API, and the API for scaling. You can send through a REST API the instruction to Azure to, for instance, add 2 more servers to the web server layer, okay? So we automated all that stuff into one process, so we could go to sleep at night without having to be rotating our people into the monitoring thing. Okay, here's where things got a little bit more complicated once we started dealing with high load and also trying to do a bit more complex things that required some transformations into the data or, for instance, consolidating stuff we had. For instance, every game you play, it's stored as a different entrance in the table store, right? But at some points, you need to know the total amount of won matches for a specific user. And there are 2 ways of doing that. You can go and maintain that consistency over each time you go and write, or you can generate it asynchronously, and I'm going to go for the asynchronous way in a minute. But what we did was, in some scenarios, use a memcache layer. We didn't have, what's the name for the new cache? The Azure cache? Fabric cache, right? So that wasn't available at the time, so we added a memcache solution. Based on that implementation over there, you can find cloudcache.codeplex.com, and we used that, and it worked really good in Azure. So we used the memcache layer to store some pre-calculated information instead of going into table store every time we needed it. Okay? So it's much more faster, and it's always on memory. It's a way of shortening the response from the web servers. So the problem was when we started dealing with information that needed to be crossed between different users, like a leaderboard, for instance. So in order to maintain a global leaderboard for the game, we created this architecture where what we did was made the web servers queue messages into the message queue, another service provided by Azure. And for instance, every time you want a match or you lose it or you type, you put a message in the message queue. And later we had a worker or a bunch of workers, depending on the load, again, that was monitored by the same monitoring system. But we had a bunch of worker roles monitoring the queue and generating pre-calculated stuff for later be consumed by the user. So it actually generated consolidated data for every user. And instead of putting that into NoSQL or Memcache for being served later by the web server, we put that directly into the blob storage. Okay, we created XML files. We put that into the blob storage. And the good thing about the blob storage, I don't know if you're familiar with that, but it's basically that. It's like making files available for any client to download through HTTP. And you can make them public, okay? So it's sort of pushing files through sort of FTP that can be later consumed through HTTP, right? So what we did there is made the Flash client consume directly those files. And the good thing about this is that you start making use of the browser cache. So if those files hasn't changed from one session to the next session you, as a user, create, then you won't download that file again because your browser will already have that version. So in that way, we optimized processing time, we optimized bandwidth consumption, traffic, and of course, you pay for what you use. So if you use less processing and less traffic, you pay less. And also, it's a way of maintaining the web servers responsive enough for the main application. Okay, so you don't need to directly put a negative impact into your web servers, but in a way you're offloading that load to an asynchronous process that can work at any time. So this is mainly for information that doesn't need to be real time. It's nothing like money or transactions. We have, of course, virtual goods transactions in our game, and all those go directly through the web server. These are mostly for historical information, for statistics and stuff that can be eventually consistent, but at some point in time, they might not be. Okay? So you can be seeing someone else stats that might be 2 hours ago stats instead of the real-time thing, but that's good enough for a game, right? So again, you need to design based on what you're doing. For this kind of game, and for some scenarios, this made a lot of sense. Okay, this is another scheme of the same thing, a diagram. You can see how, in reality, the web servers is a web server pool with a dynamic number of them. The worker server pool is another pool of servers, and you can have more or less servers depending on the load you're having at a precise moment. And also something I didn't mention before is that the blob storage can be served directly through the blob service, or you can put a CDN in front of it. So for files that doesn't change that often, you can serve them through the CDN. So you will have better performance on the edges. Okay, wrapping up the presentation. Some facts: we didn't use or need sysops or DBAs for this project. Again, we are all game developers. We had a couple of backend developers, but they weren't real backend developers, but game developers transformed into these. And again, it's the advantage of a platform as a service versus infrastructure as a service. Okay, we just deployed our solution and it worked. We didn't have to deal with infrastructures, OS, etc. Familiar tools integration. We used Visual Studio for most of our development. The deployment process is awesome. So, these games tend to be updated almost every day, or there are even days that you release twice. And the release process with Azure is really simple. It's really quick. You just you upload your content to a staging environment, you test that on the staging environment, and you press one button, and instantly your staging goes production, and production goes staging. And that's just one click. That's very, very awesome. Hot swap, as we call it. Again, the advantage of not dealing with low-level operating system tuning is that maybe we couldn't have got an improvement in performance without doing anything in our platform. Here, from one version of the operating system in the cloud to the next one, we got a boost in performance, and that was just because they improved the OS. Nothing to do with our code, and it worked really, really good. And again, that's someone else doing the work for you, in a way. So load balancing is transparent. You don't even know there's a load balancer. You don't have access to the configuration of that. It's totally transparent. You just put a number on the amount of instances you need, and that's handled for you. We had a couple of issues, like deployment getting stuck from staging to production. And when that happened, it was very early stages in the Azure history. We went into Azure when it was even a CTP product. So the good thing is you can call support and they will help. At least that was our case. We had a good relation with Microsoft Argentina, and we also were part of the BSpark program as a startup. And we had people behind the scenes that could respond to us and help us when we needed any help. Again, it's really elastic, as it says it is, right? You pay for what you use. You need more servers, you have them available instantly. You need less servers, you just hit the REST API saying I need less servers, and in a matter of minutes, you will have less servers, and you will be paying less for that. Some takeaways. The virtual machines, the instances, might be recycled by the system. That means they might be reset. You might lose memory state. So you must design for that. You know that this can happen, so you need to be stateless and have this in consideration. Table storage tips. You need to design how you're going to partition your data. You need to understand how table storage scales, and that's basically for one key, and that's the partition key. So you need to define yourself how you're going to be setting that partition keys to all your data. Okay? And you need to know some limitations of every partition. So, for instance, it is designed for being performant for less than 1,000 rows. So try not to have a query that goes over more than 1,000 rows. So it is designed for having per partition 500 requests per second. So try not to put too much load into one partition and non-load into the other. Try to balance your load in order to not going over this number. And also you need to know that you have to deal with concurrency issues. So if you want to update, and you can create your own race conditions between different threads, different machines, trying to update the same data. So if one data fails to update, and that's a concurrency mechanism that you have into table storage, you can get notice of that and retry. Okay? So it's something you need to know, but it's very easily handled. When you get into some specific situations, it's very interesting to offload from your main stack into workers that work behind the scenes to generate data that can be asynchronously consumed. Use the CDN if you're going to be international. It really makes a difference into downloading static content all around the world. And monitor and auto-scale your clusters. Today, there are some commercial solutions that work with Azure for doing this. We rolled our own, but you need to make this automatic. Okay, it's not that much effort. And the last thing, we used a lot these tools. They really help. The Cloud Storage Studio is a way of seeing your data. It connects to table storage, and you can do queries against it, see your data, transform, push some XML into the table storage, bring some information out or whatever. And Azure Diagnostics Manager connects to the Diagnostics API of Azure and can monitor all the health or memory, CPU, or whatever metrics from all your servers, and it's a very useful information. So wrapping up, we are able to create these kind of experiences in Bola thanks to Azure. So thank you, Azure. That's it. If you guys have any questions, please go to the mic. I'm going to try and answer if I can.
Yeah, I have a question about the worker role that you created to monitor the instances.
Yeah.
One, is that available on Codeplex or anything like that?
Sorry?
Is that available on Codeplex? Or is there any pieces?
No, but I'm sure there are a couple of open source projects in Codeplex that do the same thing.
So
not mine, but
were you monitoring like if CPU gets to 80%?
In our case, the only metric we monitored was CPU, and we actually monitor requests per second, but just for information purposes. Our jumps of amount of instances were done based on CPU load. Yeah.
So then if it got to a certain level, you just create another instance or add.
Yeah, the magic is how to define those thresholds. It's up to your application. Maybe you're CPU bound, maybe you are IO bound, and it's different, right?
Okay. Cool.
Any other question? Okay, guys, thank you.